Today we're going to be summarizing the paper on certain formal properties of grammars by Noam Chomsky using Google Gemini to help simplify the concepts. So this 1959 paper by Noam Chomsky is a foundational text in linguistics and computer science. It essentially asks what kind of mathematical machine is needed to produce sentences of the human language. Chomsky classifies grammars, sets of rules for building sentences, into a hierarchy based on their power. The main discovery is that as you place more restrictions on grammar, it becomes less powerful, meaning that it can generate fewer types of complex sentence structures. Here's a breakdown of the article simplified for clarity. The core idea: grammars as machines. Chomsky views a grammar not as a book of rules for students, but as a device or machine that generates sentences. That means the input is a start symbol, usually S for sentence. The process is rewriting the rules, that's the arrow symbol, and the output is a valid sentence in a language. The paper investigates 4 types of machines, starting at type 0 and going to the least powerful, type 3. The hierarchy of grammars. He introduces a sequence of restrictions at each level that adds a new rule that limits what grammar is allowed to do. At type 0, it's unrestricted, so it's a Turing machine. You can replace any string of symbols with any other string. It's essentially just a Turing machine, so it's very powerful. Type 1 is context-sensitive grammars. The restriction is when you write a symbol, a new string cannot be shorter than the old one. Okay, that makes sense. You can rewrite a symbol A into something else, but you might require it to be a specific context. For example, rewrite A only if it's surrounded by X and Y. Okay. These grammars allow for permutations, changing word order, which makes them more powerful than type 2, but sometimes too powerful, allowing structures that don't make any linguistic sense. That makes sense. When you only can increase the length of the sentences, sometimes it won't make sense. Type 2, context-free grammars. The restriction: you must rewrite one single symbol at a time without caring about its context. Context. My bad. The rules look like this. A can be rewritten as B or C, or A is rewritten as a word. Significance. This is a sweet spot for traditional grammar trees. This allows us to break a sentence into its noun phrase and verb phrase, forming a neat diagram. And, all right, that makes sense as well. But without context, it's hard to, or context free. Okay. And then 3 is finite state grammars. This is the most limiting. You can only write rules that generate symbols one by one in a chain, like beads on a string, rather than a tree. The rules effectively state: write a word and move to the next state. A can be rewritten as A, B. These are equivalent to finite automata. Okay, so the key findings are that the restrictions are increasingly heavy. So every type 3 language is also a type 2 language. And it keeps going down that. But there are also type 2 languages that cannot handle. Wait, there are also type 2 languages that type 3 cannot handle. Yes. Wait. Okay. Interesting. Self-embedding problem. This paper identifies exactly why type 2 is more powerful than type 3. The grammar is self-embedding if a symbol can generate a string that contains itself surrounded by other strings. In English, we can put one sentence inside of another. The man who the boy saw is tall. Theoretically, you can do this forever. The man who the boy who the girl liked saw. Finite state grammars cannot handle this nesting. They can't remember the beginning of a sentence long enough to close the loop at the end. Okay, so that's why type 2 is more powerful than type 3. The mirror language. So Chomsky uses a theoretical language L2 to prove L2 consists of strings followed by their mirror image. ABBA is a mirror of ABBA, forming ABBA. Type 2 grammars can generate this because they build matching branches in the tree. Type 3 cannot. Okay. Chomsky's goal was to see if English could be generated by simple machines. Conclusion: English is not a type 3 language because it has nested dependencies like if, then, or matching parentheses. Implication: we need at least type 2 phrase structure grammars to describe the tree-like structure of human language, even though those might not be fully sufficient without transformations. So it says we are at least a type 2 language, and probably not a type 0. So that means we're probably 1 or 2. Interesting. I think the overall thing that this paper was getting at was this beginning part. The restrictions on rules. And the fact that a type 0 language is going to be more unrestricted than any other language. And if you pick a language that English is defined in, well then that shows that there are things that you can do. That shows that there are things that you can't do with English or any written language, which is interesting.